Okay, here is revision 2 of my 5-card rig. As you can see, I've made some significant modifications since the last video. I've pulled out the 1300 watt power supply and put in the, I think it's LEPA G, I'm not sure, one or the other. I'll put a link to it in the comments. This power supply here delivers 1600 watts to the 12 volt rails at up to a 93% efficiency if you're using it at 220 or 230 volts, making it a platinum class power supply. I would run into some problems using the 1300 watt power supply in that I didn't have a dedicated rail to run each of the cards. The challenges this brought was that the cards couldn't all come on at the same time without tripping an overload current protection that's built into all of the power supplies nowadays. And so consequently, with only 4 rails, 5 cards, plus a motherboard, processor and everything else, you're sharing 2 rails. Each are going to have more than a single card on them. Even with the other cards undervolted, the current draw was still too much to start all the cards on their own, which once I got them running, it did alright, and we had some stability out of it. It could go a day or two, sure, and maybe longer depending. I'm not positive of how long, but it was not completely stable, and I suspect that it was the stratum disconnects that were causing the system to crash 1 or 2 days later. As it drops from the pool and all cards come back on at the same time, it would cause it to drop out. So I was unable to mine on multi-pool when I did have the 1300 watt power supply in here. That said, with this power supply, it has absolutely no problem. Can start all cards at the same time over and over and over. I haven't seen it fail once. It's been in here for 3 days and has ran for 3 days. I guess it was restarted yesterday when I was playing with it, but basically no problems at all. So to amend my earlier video, I do not recommend you get the 1300 watt power supply with 5 cards. That power supply does great with 4 cards, but if you go more than that, even under bolting the cards, I wouldn't recommend it. You can try it, maybe if you were to go a lot further down, put each card at 0.9, 0.95, which is going to hurt your clock speed and deviate from that perfect ratio of memory versus clock, which isn't, not all cards rely on that ratio. Some work great, others don't. Anyhow, with this one here, it's been a lot better. We did do some other modifications that have drastically improved the cooling of the entire system. You know, keep in mind that we're using 12 amps, somewhere around there. I haven't actually amp clamped this, but it's somewhere around 12 amps of power. So you got a lot of heat. You know, that's corresponding to about 1300 watts. It should be close to 1300 watts is being pulled from the wall right now. So each watt is basically 3.4 BTUs. It's the industry standard, either watts or BTUs, to measure heat, how much heat you're picking up. That said, you have to dissipate all that heat one way or another. Now, before, I had the 2 cards you see right here. They were on the bottom where the power supply was at. The power supply was pointed down. And that worked okay. However, we had some wasted space. It put the power supply here pointed down and didn't give me a whole lot of clearance to the fans, the Excalibur fans, on my front radiator. These fans, they work pretty good, even you know, having 1/4 inch, somewhere around there, of clearance, but it works a lot better now. Right now we've got about 1.25 inches between the back of the water block there and the fans, meaning this 120 by 240 radiator is getting a lot more air through it now. More than that, I did some replumbing of the water lines. Real interesting thing. When I was running it before, the graphics cards are all within 1 degree of each other. And basically, they were all running about 71 degrees. What that was doing is making the entire water loop, it was making the temperature of the water itself 62 degrees, or 61 degrees. Therefore, your CPU, even though it's sitting idle, is running at 62 degrees. So if you go to load any intensive CPU program, your temperature of your processor is going to jump up to 67 or 68 degrees. That's without even loading a really intensive, I would be running at 67 degrees, with about 50% CPU usage, and I never pushed it to 100%, but I'm afraid it would shut down probably. And most of that's not heat that the CPU is putting off, that's that the water loop was too hot. And that didn't start to happen until adding the 5th card to the system. 4 cards, we were totally fine. The 5th card kind of put us right at the edge. What I did, really interesting, is if you follow the reservoir here, there's 2 pumps on it. One pump comes directly out through this tube here, sends water to the triple block, to these 3 cards. Goes through the 3 cards, exits through this tube, and goes up to the top radiator. In the top radiator, gives off a lot of heat. The water line comes back out, comes back in to the reservoir. So there's one loop. The other loop is the more challenging loop. It has the CPU in it. There's problems with using a CPU with a whole bunch of other stuff, in that your CPU block takes a lot of the hydraulic pressure away. It's very restrictive compared to a water block on, say, a video card, a GPU water block. So in the past I had ran, I experimented with it, running it through with one pump, through the water block on the processor, into the back radiator, which is an 80mm thick radiator, as the one on the top is. From that radiator, I ran it into the triple block here. Now this is a triple parallel, meaning each one of these cards is more or less getting almost the exact same amount of water, and that's why they all run very close in temperature. Depending on how your water loop is set up, it works very well. However, if you take a whole bunch of flow away because you lost it in the water block on your processor, now you cannot efficiently deliver water to your GPUs, and they start overheating very quick. And that's the situation that you run into when you're doing a triple parallel. Lots of people will tell you, never use parallel, never use parallel. Well, that's crap. If you want even temperatures, that's how you get it. I've watched video after video where people series a shitload of water blocks together and then wonder why the last GPU is 15 degrees Celsius hotter than your other ones. So, triple parallel works great. Have it on its own pump. I do recommend the SwiftTech, I think it's P655. It's a PWM pump. It rocks. Water-cooled is the most reliable pump. It is PWM if you do want to use that feature to slow it down and run it at the same speed you're running your 4-pin PWM fans. I did that in the past before I had all the video cards, when I was running just one 7970 in it, and I could run it at a pretty low speed and get away with it. But when I started adding more cards, you need water to move through that system efficiently and quickly. So, we had to overcome an obstacle here. I did not want to continue feeding the processor with 62 degree water. This being an AMD FX 8350 you know, is rated around 61 or 62 degrees for maximum core temperature. I believe its maximum core temperature is 62 degrees on this processor. And so that's not a good thing if you are going to put it under a lot of load. If you're not going to put it under a lot of load, it's not a big deal. I like the ability to transcode videos. I use Air Video Server, and it streams videos for me from my Ubuntu server. It converts them into a format